Most of you all are familiar with the idea of a file. File basically means a storage area that you give a name to, okay? And we've already been using files. We've been using the .cpp files. You use the Word files. You use many files, and you're used to using these in your work as you work with your computer. Now, oftentimes we store these in a secondary storage location. Perhaps many of you put it on your flash drive, or some of you now that you have your H drive, you put it on your H drive, or you email it to yourself. So you put it someplace so that you can transport it back and forth and have access to it from multiple locations. Okay? Now, sometimes in a program, we have an external file, and that's what we're going to use in our example. And that's where we have a file that either I write to and somebody else reads from, or vice versa. Or I might have a file that I use just for the purpose of the program that goes away. That's not what we call scratch file. So that could be an internal file that's used in the program. Now, we're going to specifically talk about text files. And we're already using text files, okay? The .cpp, I think we talked about this. I know we talked about this in the beginning of the semester. The .cpp file is a text file. And what do I mean when I say that? What do I mean when I say that the .cpp is a text file? You remember? Yeah. So it saves the text of the program. So, for example, if you write int main, it simply saves the I, the N, the T, the character equivalent of each text character. How does that differ from, say, a doc file? What's in a doc file? Adam? Yes. Yes. OK. So a text file purely saves text. There's no mysteries in there. Every single character that you enter into the file is saved as its ASCII code. Right? Yes. It's under Files. It's under Blackboard. It's under next. I think it's for Tuesday. But it's listed for I'm a little early on this. I thought I'd talk about it once so you could do your homework, and then I'll talk about it again on Tuesday. Okay. So what are the different ways? I know we talked about this because I remember. What are the different ways that I can create a text file? Yeah. So I can use Notepad to create. I'm losing my mouse here. I can create Notepad to create a file. And everything I type is stored exactly as it looks. So the ASCII equivalent of T would be stored, the ASCII equivalent of H, the ASCII equivalent of I, the ASCII equivalent of S, the space. So if we save this file into the, let's put it into the, let's put it into the temp directory. And I save this as test. How big will that file be? I didn't want to open it. I just want to look at the properties. OK, so let's see if we can get more specific. Right-click, properties. OK, so it says that that file is 14 bytes. And if we count THIS space, IS space, A space, TEST, guess how many that adds up to be? 14. So a text file is exactly what it sounds like. It's an ASCII character for each text character. And that's opposed to a Word file. If I made this a Word file, it'd be a lot bigger because it would save all the formatting information. So when we use a CPP file, we do use a text file, and that's the same thing we're going to do when we do our exercise in lab on Wednesday, where we actually read from a file. We're going to create a file that we read from in the lab, okay? And so we have a variety of ways of doing that. One is to use the Notepad. I recommend you use Visual Studio because we're already there. So if you use Visual Studio and you do something like this, File, New, File, you'll see that one of your very first options is to create a text file right off the bat, okay? And now I could, might want to make this something more. Can I change the name here? No. I might want to make this name something that I can find. But whatever I type in here, if I type some numbers and I write a program then to read that, let's say I call this test. Okay, so whatever name I give that program, that's what I'm going to have to open. Why is it not? Oh, it's creating directories for me. I didn't mean to do that. Put it here. Okay, so now it's renamed it to test.txt. I think there was an easier way than the way I just did, but anyway. Okay, so that's a text file. So you have a couple of options of how to create a text file. You can use Visual Studio. You can use Notepad. Now, just a couple of background information on files, which I think is important to know as a programmer. In Windows, we have the luxury of having many characters for our file names. We put spaces in our file names and everything like that. In other operating systems, such as Unix, there are some restrictions on file names. So as a programmer, I usually advise people to not put spaces in their file names in case you change platform. So rather than calling it something, this is the coolest file ever, you might want to just say, test file 1, and avoid blanks in your names and things like that, because other operating systems do have restrictions. So I usually use these. I usually stick, when I'm doing programming and using a file, I usually stick to this 1 to 8 character restriction, just so that if I go to another platform, my file will still be recognized. Okay, so I try to steer clear of funky characters and spaces. You're all familiar with extensions. Extensions indicate, how many people are familiar with file extensions? Okay, so that indicates what type of file it is. It's not a promise. It's just an indication of what type. And there's nothing to stop me from making a CPP file that doesn't really have CPP code, but that's that would be your problem. So the idea is that these are indicators of what these types of so a lot of times what we use is, if we're going to create a text file, we use text or .dat. So in the lab on Wednesday, not only are we going to create a CPP like always, we're also going to create a text file, okay? And instead of reading from the keyboard, we're going to read from that text file, okay? One thing I always like to talk about, just briefly, people are sort of interested in this. All our data is stored on a disk, which is comprised of tracks and sectors. So when your file is stored, it is given a location on this disk. Let's say your file is stored here. And the disk has an associated table with it, which is redundantly called, can't see it on the screen, redundantly called the FAT table. And that stands for, I'm not seeing it on my, it stands for what? Yeah, it stands for File Allocation Table. And what the File Allocation Table includes, is the name of your file and your location, which is going to include the track number and the sector number. Okay? Now, the reason I like to discuss this is almost from a security standpoint. Okay? So when your file is in the FAT table, you can very quickly access your file because it simply looks up the location and finds your file. Now, what happens when you delete your file? What happens when you delete your file? It's what? Okay, so what happens to, when you delete your file, when you say delete file, it happens really fast, right? So let's say that I have something called test 1, and it's in track 3, sector 20. Okay? So does a big magnet from the sky come down and delete test 1 from the disk? No. What happens? No? Adam? Okay, well, it's really simple, actually. Okay? All that really happens is it's removed from the fact table. Okay? So that means that you can no longer access it because you don't have the location. However, what about the file? It's still there. So if you used a recovery program such as Norton and you knew what was in your file, you could actually probably find pieces of the file. Okay? And this file will eventually get written over because this is now deemed free space. But what does this mean about files that you thought were deleted? They're basically still there. You can recover them if you have not done a lot of activity, but what it means is this is why you're never supposed to get rid of a hard disk unless you've erased it, because the files basically stay there. Okay? I mean, they will get written over in time, but you don't know what's gotten written over in time. Okay? So this is always, I kind of think, an interesting point to bring up as we're talking about files. One other point is that a large file is typically not stored contiguously. It's stored in different locations throughout the disk. So what can happen is you may have plenty of disk space, but you may run out of contiguous disk space. And what do I mean by that? Sorry. What does it mean if I run out of contiguous disk space? Right next to each other. So this can actually slow down performance because your file gets very segmented. So every time you have to open it, you would have to go to all the different or access it. You have to go to the different locations. So there's a different. You may look like you have plenty of free space, but you may not have lots of contiguous space. This is not as big a problem now that our disks are getting larger and larger, but it's still a problem. And so this is something you can use cleanup utilities to move things together so you have more free up your contiguous space, and that can actually improve your performance. Okay. All right. So these are a little bit of a side, but I always just mention these with files because I'm not sure you ever learned about them anywhere else. Okay. Now, the next thing I want to talk about with files is the path. And this is one thing that I always get like kind of a bad feeling because it's great that Windows is so friendly and great that we all, don't have to worry about the innards of our machine. But I always don't have a good feeling when I don't think people have a good sense of their directory structures and organization anymore. Okay? And it's actually a very simple structure. It's just an organizational hierarchy. That if you look at your Explorer, you can see what directories you have underneath your C drive or whatever drives you have. Oftentimes you have external drives. And then you may decide to create subdirectories for that. And one of the classic examples of this, if you've actually looked where our Visual Studio files get created, what a pain that is, right? Have you seen where it puts them? I mean, you can never find them. They're like this very complex root structure, okay? So here's the deal. First of all, what is a path exactly? Can somebody explain to me what a path is when we talk about relative to a file name? Jared? So the path is the exact directory structure where a file can be found. And it may be like immediately off of C, but it may be several levels down. Okay, here's the thing. If you're opening a file and you just give the file name, it's not going to search all the directories for that file. Where do you think the program will search for a file if you don't give a directory? If you give no directory, where will this program search for the file? The current directory, which God knows where that is, right? So if you have not put that file in that current directory or project file, you won't be able to find it. So what I usually tell people to do when they do this exercise on Wednesday is to put it someplace you know where it is. It can be on your H drive. It can be in the temp. Now, one of the restrictions we have, and you've seen this, in the lab, a lot of the directories are protected, and that's for a reason. Usually the temp directory is always open, okay? So sometimes I put stuff in the temp directory for this exercise just so that it's easy for me to find. But if you have this long, elaborate directory path structure, you're going to end up making a typo or something, and you're not going to be able to find your file. So when you initially create your file, pay careful attention to where it is. Does that make sense? Okay. So the path, now one other point about the path is if a file is underneath the C drive and it's underneath temp and the file's name is junk.txt, this is the path, okay? All right, now here's where things get hairy. Because the backslash is a special character in C, if I wanted to specify that in my program, I would actually have to do 2 backslash. Okay, do you ever remember seeing this character? Has anybody seen this character in the anybody know what that does? Yeah. New lines, the new lines. And what this says, and there's a bunch of them. There's \T, which is tab. I'm not going to remember others. But anyway, there's a bunch of backslash. The backslash means that the next character is a special character. So therefore, you can't just do the path like this. Is everybody listening? Because this is, I promise to God, I'm going to be walking around, somebody's going to say, I can't find my file, and they're going to show me this path right here. So you have to specify 2 slashes when you do your path, and that's a C thing. Java has the same thing, I believe. It's just the slash is a special character, okay? So in the path name, you will have to put two, is it slash or backslash? Whichever one it is. There must be 2 of them. Okay. All right, so let's actually talk about using files now. Okay, now, input and output is slow. Input and output is slow, and you probably have experienced this. You try to save something to your disk, can't you almost see the ka-chunk, ka-chunk? I mean, it's a relatively slow operation, okay? So because I/O is slow, both writing to a file and reading from a file is slow, there's a behind-the-scenes mechanism called a buffer. Does anybody know what a buffer is? Anybody know what a buffer is? No, it's a temporary storage area. A buffer is a temporary storage area, okay? So here's the deal. Here's the example I give. So how many people live in a 2-story house? Or more than 1 story? Anybody live in a more than 1 story? Okay, so when you have something that has to go upstairs, like, let's say you have your book or you have your, shampoo or something, you want to take it upstairs, do you every single time you have an item chunk up the, run up the stairs and put that in its proper place? No. You throw it at the bottom of the steps, right? You throw the item, and then the idea is when you get a full load, you take all the items up, okay? Well, that's how a buffer works. Rather than every write going to a file as it needs to happen, it gets stored into a temporary storage area. So we put all the, now behind the scenes, we don't have to do it ourselves. So the data gets stored into this buffer, and the buffer has a size. It's pre-allocated. Sometimes you can change it. Sometimes it's determined by the compiler. Sometimes you have other ways of changing the size of the buffer. But the buffer, let's say it holds 1,000 bytes. So you put in all your data. When the buffer gets full, it then writes to the file, okay? This is all happening behind the scenes. You're not aware of this. You're just doing your writes, okay? So if you have 4,500 pieces of data, rather than doing 4,500 writes, how many writes would take place if your buffer is 1,000 long? 5, just 5. So the first 1,000 would go once, the second 1,000, so it's much quicker, okay? So this buffer is being filled up for input and output so that it speeds up the I/O mechanism, okay? And again, this is not something you have to do, but be aware that this is occurring behind the scenes.